Okay, welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 16 from the May-June 2018 0580 Cambridge IGCSE paper 2, variant 2. And this question here is about this circle center O. AB is a chord of the circle of length 12 centimeters, sorry. And M is the midpoint of AB, and OM is 4.5 centimeters. Calculate the radius of the circle. All right, so in this case here, we have what's called a chord, and we have this point M, which is the midpoint of the chord. So that this chord is cut into two equal halves. All right, so this is 12 meters. Now, one of the laws that we should have learnt and we should remember from the laws that we learnt in about circles is the fact that if you have a radius, which this would be, cutting, I mean, if you continue on, this would be the radius until the end. Cutting the chord into two equal halves, then it meets it at right angles. So when a chord is cut into two equal halves, the line coming from the center to the midpoint of the chord will meet the chord at right angles. That's something that we should know. So it's like vice versa as well. So for example, if you had a situation where you have the center of the circle and a chord. So if you knew, for example, that this angle was 90 degrees, if you knew this angle was 90 degrees, this was the center, this line comes from the center, and it cut this chord at 90 degrees, then you would know that these two sides are equal. It's been bisected by this line. The chord is bisected by the line from the center. And vice versa, like this, we know that this has been cut into two equal halves, therefore we know that this line must cut it at right angle. So I know for sure that's a right angle. I know that this is 6 centimeters. I know this is also 6 centimeters, and I know the line OM is 4.5 centimeters. And we have to find the radius of the circle. Now, the radius of the circle we can take as from O to B. Let me just draw it in a different color. So the radius of the circle would be O to B, or even O to A. So we have basically a right angle triangle. We have a triangle that's right angle that looks like this. Just draw it freehand. Okay. I know this is 4.5. I know that this is 6 centimeters here. Okay, that 6 centimeters belongs over there. Second. Let me just make it a bit clearer. So that's 6 there, and that's 4.5 here. That's the right angle, and we want to find the radius. This is the radius. This is what we're trying to find, the radius of this. And so we can use Pythagoras' theorem because we have a right angle triangle. So we can say r squared is equal to the square root of, as is the hypotenuse, the sum of the square of the two shorter sides. So 4.5 squared plus 6 squared. So r squared equals, and we can just stick that in the calculator, the square root of 4.5 squared plus 6 squared. And that gives us the answer 15 over 2, 7. So r is equal to 7.5. We just put that straight in our calculator, the whole thing. So r equals 7.5 centimeters. So r equals 7.5 centimeters, and there's the answer to that question. So I've done most of the working up there near the diagram so we could see it better. And that answers this question number 16 from this paper. Other questions from this paper will be found in the playlist that will appear in this region over here after at the end of the video. You'll also find other questions dealing with circles, and here like a video dealing with so this will be circles under, like, you know, areas and volumes and areas and sectors and stuff. It will be under that category, I guess. And you'll also have something dealing with trigonometry over here. All trick questions I'll collect in the playlist over there. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.